Welcome. We are going to start our study of matrices, and really these are a nice thing to connect to our previous study of systems of equations. When we were studying systems of equations, there's a lot of notation that we have to continually repeat over time. So we have to always write x, y, z if we have three variables and the little squiggly bracket in front of them, and it just takes up a lot of time and energy. So maybe there's a more cost-effective way of spending our time. And so matrices are going to allow us to do this. Really what a matrix is it's just a rectangular array of numbers or elements. For our purposes, we will use just numbers. So they are going to look like a nice little collection of values. You can see we enclose them in brackets. Some books and some notations use brackets, some use parentheses. Nevertheless, all we do is represent, for example, you can see the table here. We translate from a table to a matrix almost seamlessly, just representing every row and column number from the table in the matrix in that corresponding location. When we think about our systems of equations, we don't really work with the variables that we use that often, x, y, and z mainly. We mainly do operations with the coefficients. So what we're going to end up doing when we translate from a system of equations to a matrix is pluck off those coefficients. So when we do that, we're going to get what we think of as the coefficient matrix, those coefficients of x, y, and z, but we're going to join it with the solutions as well, at least in this case, the 3 and the 1. And when we join it with, or join those coefficients with those solutions, we get what we call an augmented matrix. So, for example, when we write the augmented matrix for this first system, we can take the coefficients. I'm going to start with a little square bracket. Again, you can use parentheses if you wish, but I'm going to pluck off the coefficients of x, y, x and y over here. So it's going to be 1 and 2 for the first equation, and then we have 4 and minus 5 from the second equation. I'm going to draw a little dashed line. You might see me do a solid line on occasion. It doesn't much matter. All this line, whether it's solid or dashed, is here to do is indicate that to the left of it, those are the coefficients of x and y, and to the right are the solutions. Okay, so there's my augmented matrix, and again, I kind of split it into two pieces, the coefficients and then the solutions. Okay, so that's kind of what we're going to begin with, is just translating back and forth. So for this next system, I want you to pause the video, see if you can write out the augmented matrix for the system. Again, coefficients on one side, solutions on the other. Okay, so hopefully you had a little bit of time to try it out for yourself. For this first equation, the coefficients are 3, minus 1, and 2, and then I'm going to draw my dashed line, and then on the opposite side of the dashed line in the first row we get 0. Second row, okay, again, we talk about in matrices, we talk about rows and columns just like we would in a table. So in the second row, okay, going horizontally, there is no x. So what do I put? I put a 0, okay? And then we have 1, minus 1, and then 2. For the third and final row, I'm going to have 1, 0, because there's no y, 2, and 3. Okay, so we need to be able to take a system and write it in a matrix form. Eventually, you'll see at the end of our processes here today that we need to be able to go the other way. Now this time I gave you the augmented matrix and I just want you to write the system, okay? And I did use parentheses here on this one just because that's what's available to me in the equation editor, but you could write these with brackets if you wanted to. So take this augmented matrix and now write the system of equations that it corresponds to. Okay, if we do that, we get 3x plus 2y minus z is equal to 0 for the first row, or for the first equation, really. For the second equation, again, this one is the coefficient of x, so it'd be, you can write 1x doesn't much matter to me, plus 2y plus z is equal to 1. And then lastly, we have minus x plus 3y plus 4z is equal to minus 3. Okay, and so that's just a little bit of practice going the other way. All right, so the main point of this video was to get you to translate between matrix form and systems of equations, because that's going to be our first step as we move forward in using matrices to solve a system of equations. So right now we're just kind of developing the language and some preliminary skills, and then this video along with the next video is going to lay the foundation for our entire study with matrices and systems of equations.